Hi everybody, before I will show you the question, I want to inform you about the new feature of my channel, which is now we started rating of the questions for their hardness on the scale of 10. So now on the basis of three different aspects, we scale them. So first aspect is creativity. So our question got some points out of 10 on creativity, and then second aspect is mathematical thinking, and our final aspect is focus needed for solving that problem. So our average hardness of a problem is sum of all the points on their three different aspects divided by 3. And we do this rating in the last of the video after I will show you the solution. Now, so our today's question is, if we have a triangle ABC and we draw a line from point A to the side CB which intersects CB at D, so that the line AB bisects the angle A. Now we draw a circle that is passing through the point D and A of the triangle, and it intersects AC at X and AB at Y. So if AC is equals to 18, CB is equals to 16, AB is equals to 14, and AD is a bisector of angle CAB, a circle is passing through the point D and X, then find the distance between point X and Y and also the radius of the circle. So first you please give your trial to this question and keep watching for the solution. For finding our answer, we need to learn lot more theorem, and one of the theorem says if we have a circle and we draw a chord on that, and if we make an angle through the lines that is touching the arc of the circle, and wherever these line touches the arc, the angle between them is always remain same. So the theorem says angle formed by the chord on any point of the arc is always same. Now here is a figure. First join point X and D, and then point D and Y, and then point X and Y. Now if we consider chord XD, then we can say angle XYD is also equals to angle XAD. Similarly, if we consider DY as a common chord, then angle DXY is also equals to angle DAY. Now we need to learn a pedagogy which is famously known as ratio lemma for solving our answer. So if we have a triangle ABC, we draw a line from point A to the side CB which intersects CB at D. So if AD bisects the angle A, so that the bisector angles are alpha. So by using sine law in triangle ADC, we can say sine of alpha divided by CD is equals to sine of angle ADC divided by AC. Now using sine law in triangle ADB, we can say sine of alpha divided by DB is equals to sine of 180 degrees minus angle ABC divided by AC. Now fusing these more equations and using this identity, we can say AC divided by CD is equals to AB divided by DB. Now we use this pedagogy for finding our answer. So including this whole triangle, we can say AC divided by CD is equals to AB divided by DB, and we have already given the sides, so we can say CD divided by DB is equals to 9 by 7. Now we can say CD plus DB is equals to 16, and by our ratio we can write this also as this. So finally we have DB is equals to 7. Now we need to learn again a theorem which is famously known as Secant theorem, and this theorem says if we have a circle and we draw a line from a point exterior of the circle such that this line be A, this chord be B, this chord be D, and this line be C. So by secant theorem, we can say A times A plus B is equals to C times C plus D. But we don't need to learn this theorem for our answer. we need to learn version 2.0 of this theorem, which is famously known as secant tangent theorem. So for this theorem, we extend our side AB at the edge of the circle such that this side B becomes 0 and this A becomes extended, which is working as a tangent. So by secant theorem, putting B is equals to 0, we can say A square is equals to C times C plus D, and this theorem is known as secant tangent theorem, and basically it is the part 2 of the secant theorem. Now consider this triangle ADB and DB working as a tangent and AY working as a chord and YB is working as a line. So DB square is equals to BY times BA. So putting DB is equals to 7 and BA is equals to 14, we can say BY is equals to 7 divided by 2. Now considering this whole triangle, so cosine of angle B is equals to 16 square plus 14 square minus 18 square divided by 2 times 16 times 14, and we got this by cosine law. Now doing furthermore simplifications, we have cosine of B is equals to 64 divided by 16 times 14. Now considering this triangle DYB, so cosine of B by cosine law is equals to dB square plus by square times dy square divided by 2 times dB times by, and we already found by and dB, so we have this. Now using this value of cosine of B, we can say our dy square is equals to 47.25. Now considering this triangle DXY, we know that these two angles are equal, so we can say dx square is also equals to dy square. Now we need to learn again a theorem, which is sum of opposite angles of a cyclic quadrilateral is always of 180 degrees. So what is cyclic quadrilateral? So basically it is a quadrilateral that forms inside of a circle through touching the arc of the circle. So consider the angles are alpha, beta, gamma and theta. So the opposite angles have always the sum of 180 degrees. So alpha plus gamma is equals to 180 degrees and beta plus theta is also equals to 180 degrees. So by our this theorem, we can say in cyclic quadrilateral DXYA, angle A plus angle D is equals to 180 degrees. So we can say cosine of angle A is equals to cosine of 180 degrees minus angle D. So cosine of A by cosine law in our whole triangle ACB, we can say this is equals to 18 square plus 14 square minus 16 square divided by 2 times 18 times 14. We can write this as also like this. So cosine of angle D is equals to x d square plus dy square minus xy square divided by 2 times dx times dy, and putting our values that we found previously, so we have this. And cosine of angle D is also equals to negative of cosine of angle A, which is equals to 132 divided by 18 times 14. And now doing furthermore simplifications, we have got this, and finally we have xy square is equals to 144, which is the square of 12. So we have xy is equals to 12. Now we have found xy, but now for finding our radius, we need to again learn a theorem. So this theorem says angle forms by the chord of a circle on the center is double of the angle formed by the same chord on the arc. So if we have a circle and if we have a chord, if we draw a line from chord to the arcs, then consider this angle be theta. So if we join lines from this same chord to the center, then the angle formed by these lines is of 2 theta. Now consider angle CAB be alpha and then join the lines from the common chord XY to the centers so that the angle formed is 2 alpha. Now we use the identity cosine of 2 alpha is equals to 2 times cosine of alpha is minus 1. So by using cosine of A, we can easily find the value of cosine of 2 alpha, and by using cosine law in triangle x, y and the center of the circle, so we can say cosine of 2 alpha is equals to r square plus r square minus xy divided by 2 times r square, and we already found xy is equals to 12, so we can easily find the radius of the circle. So now it's a time for the rating of the problem. So for creativity, I want to give this problem 3.5 points out of 10, and for mathematical thinking, I want to give this problem 5.5 points out of 10 because we use lot more theorems for this problem, and for focus needed, I want to give this problem only 3 points out of 10 because there is not more focus needed for this problem. So the average hardness of a problem is 4.